Hi, welcome to the third and final video in my short series on creating a custom PCB that's tree shaped and uses a ATtiny85, some NeoPixels, and a buzzer, and creates and has plays buzzer music, Christmas buzzer music. This is the third video. I'll link to the other two down below where I talked about the brainstorming and also prototyping, and then the design process. This video is just going to be a follow-up. I call it thoughts and results, so that I got my boards back from the board house and had a chance to solder one together, and I'll talk about if it met the design goals that I set out at the beginning. I guess the thing, you want to see the board. So this is the boards that came back from the board house. You can see that it's got 15 NeoPixels there. Like I say, they're the reverse mount, so they actually get soldered on the back here. And then the only other thing is your power, USB power lead, a buzzer, and then a switch to turn the buzzer on and off. The ATtiny85 and a 10 UF capacitor, just a decoupling capacitor. It's all we needed. One of my design decisions that I made was to not include the decoupling capacitor that the data sheet said it was required for each NeoPixel. I said that I found somebody on the internet that said that it wasn't needed, and so I decided to go with not having them, and it worked out pretty good. So that was a good choice on mine. For longevity, that might not have been the best point, but these guys want to see these things working, and they only come out a week or two a year, probably at Christmas time. So, yep, it worked out very well. I have a video of them working. Let's get that going. So this is I took it on my iPhone because the webcam doesn't do a good job of getting the pixel colors. So I decided to make the star pixel white always, and these are just using the random wheel function, NeoPixel wheel function, to use your primary and secondary colors for the pixels. Rather, if you did a random RG and B, then you're going to end up with a lot of washed out whitish color, different shades of white pixels. This gives you different colors for sure. All right, so we'll go ahead and play this a little bit just to show it's working. You can hear the buzzer music. See the random pixels going. I'm unplugging it. And we'll just take a picture. There you go. It's a little blurry. There we go. Oh, let's back it up a little bit. There we go. So you can see that I got my twisted wire there and everything. The pixels is good. So we'll just go on to the back side. And you can see the NeoPixels, how small they are. You know, they're easily fit half a dozen of them on my thumbnail if I wanted to. They definitely tweezer objects, and the legs of them, the negative leg has a triangle cut on it, but you need good eyes to see that. So that's definitely, I don't think they're going to be beginner friendly. So that's just my thoughts there. It took me, I got better as I went. The first couple pixels, I was just giving it a try. I found that the easiest way to hand solder these was to put a little bit of solder on the tip and then touch the pad and the little leg and let the solder flow. I used a lot of the flux. Used a chip quick pen to flux it up before I started, so that made the solder flow a lot better. Like I said, the whole project took about 30 minutes to solder, but the NeoPixels, 15 NeoPixels, probably took 22, 25 minutes or something. The other ones just about 5 minutes to get them done. One thing I'm considering, I haven't done this before, is maybe getting like a the solder paste pen and have maybe try to put the paste on them. The problem is it's a kind of expensive, and that actually this stuff has a shelf life. So I usually do 6 people at a time, so I wouldn't want them, have to be sharing tubes. So they would, I'd have 6 tubes, and I probably wouldn't do this, but a couple times through Christmas, and then they'd sit for a whole year, and I wouldn't want them to go bad, and don't really have a whole lot of use for them. But that's one option. And if I put the solder, did that, then I do have access to a hot air solder station, or not access, I own one, so I could try that and see how that works out. But I guess the other way would be to do it on a hot plate. This is a low melt temp solder, so you probably wouldn't burn the pixels up. They have about a 250 degrees Celsius top temperature, but this melts at like 138. So you might be able to get away with like a hot plate with, putting them in there and then setting it on a hot plate. But I don't have any of that equipment, so I don't know whether I want to try that or not. Might be an interesting increase my knowledge, if not, even if it doesn't get used, for my classes, it would be, something new for me to do. But anyhow, that's basically what we got. My design goals were to keep it cheap. I knew that the first 10, you're going to pay a lot more for shipping for parts for just 10 things. Like I said, I only got 20 pixels from Adafruit, just enough to do one, because they were going to get here quicker, and I wanted to make sure that I could work it. But I also ordered, you can order a couple hundred at a time from AliExpress, and get them for about 1/3 the cost, so about 7 cents compared to 30 cents. So it's probably 1/4 the cost, I guess. These 10 prototypes and enough parts to do them, it's going to be about $10 to $11 per project, with the cord and the buzzer and everything. I can give you a little bit of a rundown on the cost. The cords were under $1. The pigtail cords are 1 meter. Got USB on the other end that you just plug in, and then pigtails just power. The switch is like 50 cents. I think the buzzer's 10 cents. I got ATtiny85s from overseas. This one worked out. This is one of the ones I got, and it works. And I got them for about $1.60 a piece. And then I think 10 UF capacitor was maybe 10 cents or something. I don't know. But like I said, you got to pay for shipping on all this stuff, and the boards themselves, buying 10 of them, they really make prototyping easier, because I paid next to nothing for the boards because they had a sale going on. I think I pretty much paid 50 cents, I think, for the boards, instead of normally it's $5 for 10 boards. And Yeah, I got them for 50 cents or something. I don't know, 90% discount on that. But then you're paying $20 for shipping or whatever. So, so you're paying, $2 a board to ship them, and the boards are next to nothing. So, and then if I do another run, I want to do about 30 boards, and the price goes up on them, but you save a little on shipping by getting the more boards. But it'd almost be better to order 3 different packages of 10, but they're about the same because of the shipping. I think they figure it in or something, and I guess they got a deal with a shipping company where they get some kickback or something. But anyhow, it's the boards are going to be, $2 to $225 a piece, no matter what. No matter, seems like how many you get, in numbers under 50 probably. So I'm hoping that with cheaper NeoPixels and everything, I think I can get the price down to around $7. I mean, when you're talking about 30 cents for 15 NeoPixels, you're talking about, quite a bit of money. And if you 7 cents for pixels, you're down to less than $1 or right around $1 for them. So there's quite a big difference there. So that's where most of my savings is going to be. Hopefully the NeoPixels that come in are not duds. Nothing worse than putting a component in for a project and having the project not work. Anyhow, so like I said, I met my design goals, but I don't think it's going to be suitable for general learn to solder classes, but it may be a solder project for people that have done it before. Anyhow, if you have any questions, leave them in the comments, and thanks for watching. Have a great day, everybody.